morning. This is the last topic of AP Calculus. So it's gonna be a continuation of yesterday's discussion. Yesterday was all about revolving. This is Wasser method, but we revolve along the x and the y axis. But this time we are revolving this in other axis. So again, yesterday focuses only on revolving along the x-axis and along the y-axis. So we have volume of a solid of revolution, or the Wasser. We have formula. Volume is equal to pi, the integral from a to b, and you have r of x. Okay, the region. So we have r of x minus, this is a square, right? We're gonna square and then minus r of x square and dx. Okay, I need to clarify because we're gonna have to take the derivative of this one. Not necessarily we have to put dx right here on the capital letter R. Okay, not necessarily. As long as you have dx right here. Evelyn and Sam. Okay, so what is capital letter R? It is the outside curve, right? The outside curve. And the small letter r is the inside curve. Okay, so we denote that capital letter R is the radius of the outside curve, and the small letter r is the radius of the inside curve. Okay, any question? Again, yesterday one of you questioned why there's no dx, and I just write, but not necessarily, so long as you have dx right there. So this is in terms of x, right? But in terms of y, so what to do? Adeline, can you stay here? So let's take a look on problem number 1. So problem number 1 says, find the volume of the region enclosed by y equals square root of x. So I'm gonna change color for this one. So normally we have to can I choose green for this function, y equals square root of x? So the graph of y equals square root of x is this one. So that's the green. I don't have to continue because what we're after is the region bounded by these two curves. Okay, and then I'll do blue one for the parabola y equals x squared. This is the parabola, but I just, as I said, what I'm after is this one only, because this is the region that we're gonna revolve. So Okay. So we're gonna revolve this. This is rotated about the line y equals 2. So this is the line y equals 2. Um, so it's being revolved right here at y equals 2. So the green color is square root of x, right? So the green color is square root of x. And the blue color is x squared, or yeah, x squared. So y equals x squared. So it is a region enclosed by two curves, a parabola and a square root. Okay? And this region right here is being revolved along the line y equals 2. So this means, can you imagine if we revolve this one right here at 2, which means the curve goes this way for the green. Okay? So we're gonna trace the green color. So right here we know that the green color is, what do you think? If we revolve, it's gonna be the inside, right? The green is the inside. Did you get me? Okay. So it's being revolved right here. So this is the center. So if this is revolved, so this will be, the green goes this way. Oops, sorry. It's not exactly a curve. Is that the right graph? Let's try to adjust. Okay. This slides all the time. Let's just have that, okay? And the blue is on top if we revolve this one, right? So the blue is right here. Okay. So so that means this right here is a circle, right? Okay, this is a circle, and this is also a circle. So it's being revolved. But take note that the line of revolution is y equals 2. Okay, so our basis right here is the line y equals 2. We all know that if this is our basis, so we can see right away that the small r is the green from the line y equals 2. Is this clear?
Yeah.
So we denote this one, the green is the small letter r. From the axis of revolution. Do you get me, guys? Okay, which means if we take a look right here along the x-axis, our upper curve is this line. Do you get me? and the green becomes the lower. Clear. On the other hand, the blue color, still, this line is the upper curve and the blue is the lower curve. But since this is the outside, so this is the capital letter R, the blue. Clear, guys? Okay, the blue is the capital letter R. Or the big R, since this is being rotated right here along this line. So the blue is the outside and the green is inside. Okay, so the green is the small letter R and the blue is the capital letter R. Now, so back to the formula or volume. So what's the formula for volume? So we're gonna consider now the upper curve minus the lower curve. Okay, you get me? So shall we start first on the blue color? The blue color. So volume is equal to pi the integral, and we can see from this graph that the limit is from along the x-axis is from 0 to 1. Okay, so from 0 to 1, and we're gonna have the top minus the bottom. Okay, so for blue, what's the top function? It is the line y equals 2. So how we write now? This becomes 2 minus. Okay, I'll do color coding for you to understand. Okay, so I'll do color coding. So this time we have 2. Okay, to be subtracted by the bottom, the blue color. Do you get me? The blue color. So what is the blue color? It's gonna be x squared. Okay, so x squared. And then we're gonna have square. Or can I just have this one? Can I just have like this? And then what's next? Minus. We now have the small r. Okay, the small r. So what constitutes the small r? Look at this. The small r is, I'm colorblind, guys. What color is this? Blue. Aqua. Aqua? Okay. And then, do we have the green, right? The aqua and the green. Do you get me? So what is the upper curve in this case? The aqua is the upper, and the lower curve is the green. Do you get me? Okay. So how we write now? 2 minus, oops, as I said, color coding. Sorry guys. So 2 minus what? Radical x. And radical x is green, right? Okay, radical x. And then we're gonna have this and then square. And this is x. Okay? Now, again, in the actual AP, you don't have to solve for the volume itself, but what is important is for you to set up the integrals. Okay? Because an AP corrector is only focusing on how you formulate the integrals, how you set up the integrals. So, is this clear, guys? Is this clear? Okay, very good.
I think I did, but like the real hard. I'm not trying to take any calls.
Even in clear response, you can have it this way only. You don't have to solve unless it is specified. But most of the time, if it says volume, it's gonna be a simple one. Okay, a very simple one. Even in the multiple choice. Now, as I said last time, you have a lot of resources where to go for self-review. Either you go on AP Central, what else? Khan Academy. And there are also a lot of videos for YouTube. And you can also subscribe on my YouTube channel. My name. Okay? So,
Post notice.
is this clear, guys? Is this clear? So again, this is the axis of revolution. So this from this graph, this is now the upper curve. Then the inner right here and the outer. The outer curve is the blue now. So and then being rotated. So this is the axis of revolution. And then you're gonna have to formulate the integrals, okay? And as I said, you don't have to solve for the exact volume of this. Clear, guys? So always start at the axis of revolution, okay? So this time the axis of revolution is this one, so we're gonna have to start by setting up the capital letter R and the small letter r, so you can figure out. And as I said, color coding is very important for you to understand. Okay, we only have 2 examples right here, and after that you will work independently or you can collaborate with your partner for the practice. Now, so far clear?
Yes.
So moving on to the next problem. Can I move this up? Are you done? Done? Okay. So problem number 2 says, find the volume of if the region enclosed by y equals x squared plus 1. So it's a parabola that is being shifted up 1 unit, right? Okay, and then the line, this is line 2x plus 1. So therefore, this is the y-intercept, so it's gonna be 1, right? And is rotated about the line y equals negative 1. As I said, we're gonna do color coding. What color you want me to put for the line? Pink. Green.
Is it pink?
Okay. We'll use green for this line.
Yes, sir.
But as I said, I'm just after of these intersections of 2 regions. Okay? So I'll have the green right here.
You tried.
This is the green. I'll make it bold. Okay. And then the parabola is blue. Okay? The parabola is blue. And where is the axis of symmetry or revolution? So we have a line equals negative 1. So before that, this is the region that is being revolved right here. So it's gonna be Y, right? You're gonna revolve right there. So this is a particular region that we're gonna revolve. So far, question? And I'm gonna have a line. What color you want me to use for the line? Shall I take
Pink.
purple?
Purple. That works.
Close enough. At x equals -1.
That works.
Okay, so right here, this is being revolved in this. My line is not straight. Sorry, guys. So it's being revolved right here. So can we draw now on this side? If we revolve, this is the line. X equals -1. Okay. So the outside, if we revolve, is the blue, right? If this is being revolved this way, so the outside color is blue and the inside color is green. Okay, guys. So I'm gonna draw the blue color.
Under the sea.
Oh, sorry. So it's gonna be right here. Okay. 5. I hope.
Most attractive boy. Torta pounder, I heard you getting one. Oh, okay. I'm sorry. Everybody go to torta pounder.
And then you can have a lime green, right? The green color. So I'll make it.
Oh, I'll be so proud of you. Are you gonna play the torta pounder? No, I'm not. It's colors? I'm not. One meet that I think. One I did. Only. Got a scholarship for the torta pounder association. And you have to be a torta pounder certified. And the one who
You have to show proof for it.
yeah, the one who the one who created the big torta ones.
Okay. So we have
I think it's a scholarship.
a circle right here, right?
No, it's
This is a circle, and this is a circle. And we know that the limit, and this is another circle right here.
who are you talking to?
And we know that the limit starts from 1 up to 5, right? 1 to 5. You get me, guys? So it's being rotated right here. So how we set up the integrals now? Could anyone volunteer to set up the integrals? Again, we don't have to solve for the volume. It's just to set up the integrals. So let's start from the line. And I'll have the green color. What is green color from the line? So shall we start from this up to here? Okay. Green color. Is it the small r or the big R? The small r. Why? What's the reason why this is a small r?
Because it's close to
The radius form right here is inside. Okay, so this is small r. And what do you think is our big R? Okay, the blue. Okay, this is our big R right here. Okay, clear guys? Any volunteer to set up the integrals now?
Yeah, let me do it.
Okay, let's wait for Chris.
Wait, which Chris?
It don't matter.
No, not Ramirez.
Leo.
Ojeda.
Oh.
Or either Chris or Anthony. Or Joseph.
Joseph. I heard Joseph wanted to do it.
So what's the limit now?
I got it.
Along the y-axis, so the limit is from 1 to 5. Okay, from 1 to 5. Okay, I'll start right here.
I got it. I got you right.
Now remember, one thing, hold on first, Chris. Remember, this is revolve along the y-axis. So imagine yourself right here looking at, imagine yourself, you're right here, you're looking at that side, okay? So, here guys,
So it's dy, right?
so if you look at this one, what is your upper curve? The blue. And your lower curve is the purple. Right? And right here for the inner curve, for the inner, your upper is green. And purple is your lower. Okay, Chris? Make your writing nice.
Oh, that's hard to do. That's crazy.
So Danny has a
Daddy already had the bottom
reaction right away.
My good? D, I think Y.
Okay. So Danny has a reaction.
Danny Valley reaction.
Now guys, you need to be careful. Careful. The rotation is along the y-axis, so what to do with the given function?
Oh, it's Y.
Expressed in x equals, right?
Ooh.
Did you get me?
You're right.
Okay, so it's better to commit a mistake because the next time you will be aware. Okay?
I didn't even realize that. Tripping.
Okay, so what to do with this? First,
Erase it.
we have this. Chris, can I erase?
Yes, you can.
Okay.
Oh, you just broke up, so
Damn.
right over to.
Okay. So first is the function y equals x squared plus 1. Since the axis of revolution, it is being revolved along the y-axis, so we're gonna change this into in terms of x. So we have to subtract both sides by 1. So the left side is y minus 1 is equal to x squared. Therefore, we're gonna take the square root. So this means y minus 1 is equal to x. Okay, this is now the x. Okay, guys, clear? So again, we need to be careful all the time. But what is this? What color is this? The parabola, so the blue. Can I change this color into blue? So you can. So I'll have to change this into blue.
I just choked in front of the camera. front of the fucking YouTube listeners, like the thousands of subscribers are just seeing me.
Okay, so the blue color now is y minus 1. Square root of y minus 1 is x. Okay, so this is the x for the blue. And what's the next one? The line, which is green, right? So the line green would be y equals 2x plus 1. So this means y minus 1 equals 2x, right? And then what to do? Divide by 2. So, which implies that y minus 1 over 2 is equal to x. Or we can rewrite this one as 1/2 y minus 1/2 is equal to x. Okay, you can have this. It's green. So therefore, we're gonna start on volume is equal to pi. So volume is equal to pi, the integral from 1 to 5. Okay. So the blue minus the purple. You get me? So I'll do color coding. The blue minus the purple. Make sense, guys? Okay, and then square. Okay, so your guide is the color. You get me? And next, minus so what's next, guys? The green minus the purple. Okay, so the green
92, I don't like it. Too close to 90. Me too. I want it to be like 95. I wanted to be 7
minus the purple. Okay, so I want you to continue by yourself now. I give you a guide, color coding. Yes,
Okay.
yes, Chris.
Why wasn't it like the last problem where?
Oh,
it was
because it's
the
white
purple
X.
minus
Say it loud.
why wasn't it like the last problem where it was the purple minus the blue, purple minus?
Because it's Y minus X.
Okay, as I said last time, imagine yourself standing here and look at there. Focus on this color. So what is your upper curve? The blue, right? And what is the lower curve? It's the line. You get me? So the blue minus the purple. And then what's next? The green minus the purple. Clear now? That's why I do color coding for you to continue by yourself. Don't depend so much on me. Don't say, Mister, can you write the equation? No. I am guiding you. And who is learning?
We are.
You are learning, guys. So I just give you color coding for you to continue, okay? And anyone wants to stand and deliver? I think Danny, you want it? Okay, shall we give Danny a round of applause? Let's go, Danny. Want it?
I want it.
He's fucking ripped. He's jacked. Show YouTube your guns. Oh, I have the wrong way.
Show YouTube your double D's, Danny.
It's a beautiful handwriting, man. Where was this back in Canada?
You might ask, why +1, Mr. Roy? Minus and then -1. What is negative times -1?
Positive.
Positive. So that is right. He wrote right away positive.
He said he could stop bouncing. Violent reaction.
Is that a violent reaction?
Oh, yeah.
So Chris has violent reaction according to
That's the
him.
wrong purple. Wait, hold on.
That's the wrong purple. There you go.
Okay. So shall we give Johnny a round of applause again? And this is correct, guys. This is correct. Okay. So color coding helps you a lot understand, right? Color coding helps you a lot understand.
I'm red, green color.
Okay. So you can now work by yourself or with your pair for the practice.
You're my favorite.
And if you have questions, just let me know. So this is now an independent or pair share. So this ends our topic and the entire course for AP Calculus. Okay, so we can now start with the review after the unit test. Now we are focusing on the review. Our test, your test will be on May 14 or 13. I'm not sure of the date. As long as it's May, yes. Unit test. So I'll give you time to study tomorrow. So unit test will be on Thursday. Okay? And then as we come back, when is the no school on Monday, right? No school on Monday. So we're gonna start the review. We're gonna start the review Tuesday and all the way before the actual AP test. Okay. Thank you guys. So is calculus exciting? Very much exciting and challenging also, right? Okay. And I'd like to thank 3 students who participated in an online AP readiness. No, I didn't see you, Tyler. Were you? I keep tracking all those participants. So it was Chris Ojeda, Anthony Ramirez, and Manny Nunez. Okay. Okay. The next AP readiness, which is face to face, will be on the 5th of April, and I am one of the instructors for the on face to face. But if you wanna go on your own, you go on your own. Okay.
I'm not a UCLA. I'm a UCLA.